Hello students, today we will study about a projectile motion. Now before we start on about the projectile motion, let us see what is a projectile motion. You have studied about motion in a straight line, that was a one-dimensional motion. Projectile motion is motion in a plane. Motion in a plane means it is two-dimensional motion. Now whenever any motion is two-dimensional or any vector quantity is two-dimensional, then you have to resolve it into the two different components. So this two-dimensional motion can be easily understood when we resolve it into the two components. So it becomes two one-dimensional motion taking place simultaneously at same instant. So let us assume that if this motion is in a plane, that is an xy plane, so I will resolve its quantity, which are vectors, into an x component and a y component. So it will be easier to deal with the projectile motion if the x component are studied separately and the y components are studied separately. So actually this two-dimensional motion is nothing but two one-dimensional motion taking place simultaneously at same instant. So we will resolve this motion and it will be easier to deal with this projectile motion. Now let us see a simple example of a projectile motion. Now in this example, let us assume that a football is placed at the origin of the Cartesian coordinate system. For simplicity, we assume that a motion is in xy plane. So initially, the football is assumed to be at the origin of the Cartesian coordinate system. And suppose this football is kicked with initial velocity v0, making an angle theta with the x-axis. So here a body is projected by making an angle theta with the x-axis. So this angle is also sometimes referred as the projectile angle, the angle by which a body is projected. Here we have assumed that this angle is with respect to the x-axis. Now we all know that when this body is projected, it will follow a parabolic path. So we will also prove this mathematically, how this body will follow a parabolic path or why the motion is parabolic. So that will be proved mathematically. Now when this football is kicked at different instant, see these are the different instant, these are the position of a football at different instant. So as soon as you kick it, the football will be here at some time, here at some time, here at some time. So these are the different locations or different positions of a football. Now here the football is going up, that is it is moving against the gravity, as well as it is also moving in a horizontal direction. So if I take up this instant, the body is at this much distance along the x-axis. So the body is moving along the x-axis as well as it is going up. So there will be a y component also. So these are the different components. So here the body is moving upward as well as it is moving in a horizontal direction. But at the same instant, if we see the acceleration due to gravity, it will be always vertically downward. So in a projectile motion, the acceleration due to gravity is always towards the center of the earth. It means the gravity in this motion is always vertically downward. That is minus g. So at each instant we will take a gravity to be minus g, because when the football is being kicked, it is moving against the gravity. So minus sign indicate the opposite direction. At the same time, there is no gravity along the horizontal axis. So this is the horizontal component. So at any instant, I can draw x component as well as y component. At this point, the body is in a plane. It has two components, x component and y component. So you see the gravity is vertically downward. There is no horizontal component of acceleration. So here ax will be taken as 0. So when I resolve this acceleration due to gravity into the two components, we will arrive at this conclusion that ax is equal to 0 and ay, that is the vertical component of acceleration due to gravity, that will be taken as minus g. So in projectile motion, the gravity is always vertically downward and it is constant. So this is the one characteristics of a projectile motion. In a projectile motion, the vertical component or the y component of acceleration due to gravity always remains constant at any instant, and the x component of acceleration is always 0. Now since there is no acceleration along the x-axis, so the velocity at any instant will be constant. So horizontal velocity at any point on this parabolic path will remain constant. So you have a two condition now in a projectile motion. First thing is that projectile motion is a two-dimensional motion, that is motion in a plane. So we will resolve it into x component and y component, and we found that the gravity is always vertically downward at different points on the path of a projectile. So y component of acceleration will always remain constant and its value will be minus g. Whereas because the acceleration due to gravity x component is 0, the velocity along the x component will always remains constant. So initially when the velocity is thrown or kicked, here we have taken an example of a football. So if a football is kicked with the initial velocity v0, we will resolve it into v0 x and v0 y, that is the x component of initial velocity and y component of initial velocity. And because ax is 0, v0 x will always remains constant whatever is the position of an object at any instant. Whereas the vertical velocity, because it have a vertical component, acceleration due to gravity have a vertical component that is fixed minus g, but it has an acceleration. So the velocity v0 y, that is the initial velocity, but at different instant the velocity will keep on changing. So while a body move on a parabolic path, at this point the velocity will be less than the initial velocity because the body is moving against the gravity. Again we will resolve it and we will find that the horizontal component of the velocity will always be equal to the initial velocity, and the vertical component of the velocity will keep on changing. So let us assume that you kicked a football with a speed of 3 meter per second. Now while going up, this is what the initial velocity we have taken. So while going up, its velocity will keep on decreasing. Say it becomes 2, then it becomes 1. At this point, this is the highest point. Here the velocity y component will become 0, but there will always be a horizontal component which is constant v naught x at every instant. This will be v naught x. Here it will be v naught x. So which component is changing? Only the y component. So if I take the velocity is v1, here it is v1y, that is a y component of velocity. It will change because there is an acceleration against a gravity, but v naught x will always be equal to v naught. V naught x will be equal to v1y. At this point, the vertical component of the velocity becomes 0. So if it is being kicked by 3 meter per second, at this point it is 2, then at this point it is 1. Say this point it will become 0. Then the body will start its downward motion. Again the speed will increase. Here it becomes 1, 2, and when it strikes the ground, again its speed will be equal to 3 meter per second. So this is how we will be dealing with the projectile motion. These are the basic components of the projectile motion. You have to remember this concept that projectile motion is 2D motion. So we resolve it into a 2 components. The gravity along the y-axis is always along the y-axis, which will keep constant. The x component of acceleration due to gravity is 0, so the velocity along x-axis will always be 0. Let us analyze the projectile motion. Suppose a body is projected from the origin of a Cartesian coordinate system and it will follow a parabolic path. Now this is a body which is projected making an angle theta. Let us say the initial velocity is v naught and the angle of projection is theta. So we have projected a body where v naught vector is initial velocity and theta is angle of a projection. Clearly, the body is being projected from the origin, so initial position, that is the position x component of position, x component of initial position is 0. So x naught is equal to 0. Y naught, which is the y component of initial position, that is also 0. Since it is a 2D motion, we resolve each and every quantity related with the motion into the 2 parts. So that is the x component, and on another side we have y component. Here x naught is equal to 0, here y naught is equal to 0. Now what is the initial velocity? That is v naught vector. So we resolve this initial velocity into 2 components. This is v naught x, that is the x component, and this is v naught y, that is a y component of an initial velocity. And we know that v naught x can be written as v naught cos theta and v naught y will be written as v naught sin theta. So this is the initial condition. So initial velocity was 2D. We resolve it into 2 different components, that is the x component of initial velocity, that is the y component of initial velocity. Now let us try to find out first the path of trajectory. Path of trajectory means what will be the path a projectile will follow after being projected by an angle theta. Now acceleration due to gravity, that is y component will be taken as minus g and x component will be taken as 0, because at each and every position, at each and every point, the acceleration due to gravity is vertically downward. So ax is taken as 0, ay is taken as minus g. So we defined a projectile motion, a motion in which a body move with constant vertical acceleration, and constant horizontal velocity. Since there is no acceleration along the x-axis, so the horizontal velocity at every point will remain constant. Now at any instant, if I take a different instant of the path of a body, suppose I take this instant, so here we have a velocity, it will be less than the initial velocity because the body is going in the upward direction. So and at any instant the velocity should be drawn along the tangent. Let us assume that a velocity is v1 at this point. So again I have to resolve it into two components. This component is v1 x and this will be equal to v1 y. So v1 y, that is a first instant, so let us name it as a first instant 1. v1 y will be equal to v1 sine theta, but v1 x will be written as v0 cos theta because the acceleration along the x-axis is 0. Now you can find out this thing by using the first equation of motion. We know the first equation of motion is v is equal to v0 plus at. Now if I say write the x component of this equation, so it becomes vx, v0x, ax. Substitute ax here, so it becomes 0. So this term is eliminated. So v0x, again v0 cos theta. So here time is 1, say t1, first instant. So at any instant, whether it is v1x or the body is at this point, again suppose the you have to find out the velocity at this point. Say this is a second instant, this is the first instant. Again I will write the equation y2x is equal to v0x plus ax t2, where t2 is the time for a second instant. Again this term get cancelled. So again and again the value along the horizontal comes out to be v0 cos theta. But the velocity along the y-axis will keep on changing. At any instant you can always draw a tangent. So this is a tangent drawn on the parabolic path. So this should be these two concepts should be clear, that it have a constant vertical acceleration and it have a constant horizontal velocity. Now let us find out. Now by common sense we know that it will follow a parabolic path. Such path is known as a parabolic path. But let us try to find out mathematically that it will follow a parabolic path. So the first subtopic related to the projectile motion is path followed by projectile. Any body which perform projectile motion is sometime referred as projectile. So it is a path followed by the projectile. Path is also known as the trajectory of a projectile. So whatever path a body follow, we refer this as trajectory of a projectile. It means, first thing is, as the body perform a projectile motion, its x and y component will keep on changing. Its x and y position will keep on changing. The initial position is 0 because the particle was projected, or a body is projected from the origin. But you see this, as the body follow a projectile path or a parabolic path, at this instant, this is its x position or x coordinate, this is a y coordinate. At this point, when the body or a projectile reach at this point, its x component, this is its x component, say this is x1, this is x2, this is y1, this is y2. So at any instant, let us consider this instant. So this will be its x coordinates, say instant number 3, x3, and this will be its y component, say instant number 3, y3. So the components, x component and the y component of a projectile keeps on changing. It is moving along the horizontal axis and it is going in the upward direction, and this is its maximum height. So this portion or this vertical component will be denoted by capital H. Capital H means the height achieved by the projectile, that is the maximum position. So that will be the x component and this will be the y component. So here y component will be denoted by H. So at different instant, the coordinate will keep on changing. So to find out the path followed by the projectile, we first apply the equations of motion. Remember, you have only three equations. V is equal to V naught plus 80. Second, displacement is equal to V naught T plus half 80 square. Third, V square minus V naught square is equal to 2AD, where D is the displacement. You have only three equations. Now I want to find out the position of an object at different instant. The different instant means the time. The time will be given to you. So what I have in this equation, I have an initial position, initial velocity and acceleration. We don't know the final velocity or velocity at that instant. It means the final velocity or velocity at time t is not known till now. So if I see this equation, first equation cannot be applied because we have a final velocity. Third equation also consists of a final velocity. So we are left with the second equation. Now this second equation, D is displacement. D is displacement. Displacement is written as the final position minus initial position. So what will be the final position of an object? X minus x naught, that is in the place of D, I am writing x minus x naught. That is equal to V naught x t plus half ax t square. That is the x component of this equation. This is the x component of this equation. Similarly, the y component of the equation is y minus y naught is equal to V naught yt plus half ay t square. So if different instants are given, say it is given that find out the position of an object after 1 second of its projection. So you know when the body is projected, after 1 second it will be somewhere here, after 2 seconds it will be here, 3 seconds, 4 seconds, means at different instant its x and the y coordinate will keep on changing. So this equation can be used to find out the x coordinate and the y coordinate of a projectile at different time. Here the instant we have taken is t. Now initial position is 0, so x is equal to V naught x. Now what is V naught x? So directly I will write here V naught cos theta t. So this x naught is 0. V naught x is V naught cos theta t. Ax, again Ax is 0. So this term is eliminated. So this is the first equation which is useful to find out the x coordinate of a projectile at any instant. For example, in a numerical, if I say find out the x coordinate of a projectile after 3 seconds of its projection. So you simply substitute t is equal to 3 seconds, where initial velocity and the angle of the projection will be given to you. Similarly, y naught is equal to 0. So this equation becomes y is equal to v naught y. V naught y means v naught sine theta into t. Ay is equal to minus g, so minus half g t square. So this is the equation for the y coordinate, equation number 2. So these equations which are written in a box can be useful while solving the numerical. So these are the two general equations which will give you the x and the y coordinate at different time. So time will be given to you. Now the question is, what is the trajectory of a projectile? Trajectory means what path will be followed by a projectile. So we eliminate t from this equation. Because we have to find out the path, we can use these two equations and eliminate t. So from this equation 1, t can be written as x upon v naught cos theta, that is say equation number 3. This equation number 3 is substituted in equation number 2. So y is equal to v naught sine theta. In the place of t we have x upon v naught cos theta minus half g t square. T square means x square upon v naught square cos square theta. So we have eliminated the equation, we have eliminated the time t from this equation 2 by substituting equation number 3. Now here v naught is cancelled. Sin theta upon cos theta is tan theta. So our equation becomes, so this equation can be written as y is equal to v naught cancelled, x tan theta minus half g upon v naught square cos square theta x square. So this is the equation of motion. By applying this second equation, we have eliminated t, or we found x coordinate and y coordinate at different instant. Now this is the most important equation which connect the y coordinate with the x coordinate. This is equation number 4. Now how mathematically it can be said that a body will follow a projectile motion. We know that the body has followed projectile motion, we have considered this, but mathematically every path or a trajectory have a standard equation. For example, if any body is moving in a straight line, then mathematically the form of that equation is y is equal to mx plus c, where m in mathematics is referred as slope, which we used to find out using the tan theta, and c is constant. This constant may have any value or it can be 0. So if I write a equation y is equal to 5x, example, take x is equal to 0. So y is equal to 0. X is equal to 1, y is equal to 5, x is equal to 2, y is equal to 10. Like this, if I plot a graph, the trajectory or the path becomes a straight line. So mathematically, if we have this equation, y is equal to mx plus c, then the trajectory is a straight line. So this is called as the standard equation of a straight line. Similarly, the standard equation of parabola is y is equal to ax plus bx square. Like this, we have mx plus c. So in the parabolic equation, this is the standard equation of parabola. That is, y is equal to ax plus bx square, where a is again constant, b is constant. Now you see this equation 4. You compare this equation 4 with the standard equation of the parabola. They are similar equation. So from this equation 4, so we can write that equation 4 is similar to standard equation of parabola. So projectile will follow parabolic path. So projectile will follow a parabolic path. So from this equation, we have mathematically derived this equation. So we can say whenever a body is projected, making an angle theta with the x-axis, it should follow a parabolic path, because this equation comes out to be similar to the standard equation of a parabola. So if I compare these two equations now, so comparing equation 4, so you see that a is constant, so a is equal to tan theta. A is equal to tan theta. And b, so if I compare b, it becomes minus g upon 2v0 square cos square theta. So b is a constant. Now see the values of a and b. It is theta, so a is constant, b, g is constant, v0 is a velocity by which a projectile is projected, and theta is the angle by which a projectile is projected. So a and b are the constant. So we conclude from this derivation that a body will follow a parabolic path. Now let us see the second part of the projectile motion, that is time taken to reach maximum height. Time taken to reach a maximum height. So when a body is projected from the origin, making an angle theta with the initial velocity v0, at some instant the body will be at this point. This is the point, that is the midpoint of a parabolic path, that is the center point. See, this is exactly divided into two halves. So how much time a projectile will take to reach at this point? The vertical component, later on we will see this vertical component or the vertical position will be denoted by h. Now at this point, the velocity is along the tangent, that is along the x-axis. So we know that the velocity along the horizontal component will be equal to v0 x, that is v0 cos theta, which remain constant throughout the motion. But here the vertical component of the velocity, becomes 0. So when the body was projected by some speed, say 20 meter per second, so its speed will keep on decreasing. Let us assume at this point it is 10, at this point it is 5, at this point it is 2, at this point it is 0. So when I say at a maximum height the velocity is 0, I mean the y component of the velocity is 0, because in projectile motion the horizontal component of the velocity always remains constant, because x component of acceleration was 0. We have seen that in the previous topic. So at this point, if I say whether the velocity is 0, so only the y component of the velocity is 0, not the x component. So at a maximum height, a projectile do possess the velocity, but only a horizontal component. Otherwise, its vertical component, say this is v1, this is v2, this is v3, this is v4, it will keep on changing. The vertical component of the velocity keeps on changing, but a horizontal component of the velocity at any point does not change. Keep this in your mind. The horizontal component of the velocity will always be equal to v naught cos theta. Now I have to find out the time taken to reach the maximum height, which is some time denoted by Tm, m for maximum. So how much time a projectile will take to reach the maximum height? So let us analyze the things again. Now Vy is equal to 0 and Vx will be equal to V naught x, that is equal to V naught cos theta. Now again you have three sets of equation only. The first set was equal to V is equal to V naught plus AT. Second was displacement was equal to V naught t plus half AT square. And the third set was V square minus V naught square is equal to 2AT, where D is a displacement. Now you see that we have to apply any one of this equation. I have to find out the time. So in this equation there is no time. So this equation cannot be applied. Now you are left with first equation and second equation. But we know that at the highest point the velocity y component is 0. So it is better if we deal with this this equation, because again the x and y coordinates are not known to us directly, but you can find out the x component and y component at different instant by the equation number 2 and 3, or in the previous section we have derived. But for at this point we don't have the x and y component value, so we cannot apply second equation. You are left with first equation. So Vy is equal to 0. So if I write y component of first equation, it can be written as Vy is equal to V naught y plus Ayt. There is no use of writing the equation x component, because Vx is equal to V naught x plus Axt. Again Axt is 0, so this term is cancelled. So this is V naught cos theta, that we have already taken, or we already know that a horizontal component will always remain constant. So we are left with the y component. Now the final velocity, that is the velocity at a highest point, not a final velocity, it is a velocity at a highest point, and that also y component is 0. V naught y, which can be written as V naught sine theta. Ay can be written as minus g, and t can be denoted by Tm, where Tm will be read as time taken by a projectile to reach a maximum height. Therefore, Tm can be written as V naught sine theta divided by g. So this is our next equation, say equation number 5, where Tm is the time taken by a projectile to reach at the maximum height. So you have to remember this equation. We will continue this topic in the next lecture. That will be the part 2 of a projectile motion, where we will see what is the maximum height achieved by a projectile, what is the range of a projectile. The horizontal distance of a projectile is called range, and what will be the time of flight. Time of flight means in how much time the body will return back to the earth. Initially it was projected from the origin. Now for how much time a projectile remain in air or in how much time a projectile will return back to earth is called as a time of flight. So in the next lecture we will derive about the time of flight, the range and a the maximum height achieved by a projectile. Have a nice day.